Today we will discuss motion under gravity in a two-dimensional frame. Okay? Motion under gravity in a two-dimensional frame. So let's assume that we have a frame of reference like this, x and y axis, and let's also assume that we project a particle from here, the origin, with a velocity u naught in an angle alpha naught. Okay, so the initial component of this velocity along the x-axis, which we may represent as x dot at t equal to 0, that is dx dt, the velocity along the x-axis initially will be u naught cos alpha naught, and similarly y dot at t naught will be u naught sin alpha naught. So we assume that a particle is projected with initial velocity u naught from the origin, and we will establish that its path will be a projectile, parabolic path. This is the highest point reached by the particle. Now let us see the underlying mathematics within this. This many of you have done it in your +2 level course. Anyway, let us see the mathematics behind this. What is the equation of motion of this particle which is being projected in a velocity u naught at an angle alpha naught with the x-axis, or with the horizontal direction, we should say. Since this motion is taking place only under gravity, we should remember that the only acceleration or the only force acting on this particle is mg, and we assume that the mass of the particle is unit, m equal to 1. So actually the force or the acceleration, that the same, and that is g downwards. That means in the negative sense of y-axis, isn't it so? And the particle in its path has coordinate xy at time t equal to t. We can assume that this is t equal to 0, or initial position, origin, x equal to 0, y equal to 0, and x naught, x dot and y dot are given by this. So what is the equation of motion? The equation of motion is y double dot, or d2y dt2, the acceleration along the y-axis is minus g, and x double dot we have 0, isn't it so? Quite simple. So this is the equation of motion or acceleration of the particle, and if we take the first integral, we obtain y dot is equal to minus gt plus c, c is the integration constant, and x dot is equal to c prime, that is also the integration constant, isn't it so? Since x double dot is 0, x dot will be c prime, and y double dot equal to minus g gives y dot equal to minus gt plus c, and then we use this initial condition that x dot is equal to u naught cos alpha naught and y dot is equal to u naught sin alpha naught at t equal to 0. So this gives, when you put t equal to 0, y dot becomes u naught sin alpha naught. So the value of c is u naught sin alpha naught, and you can replace it like this, and x dot is u naught cos alpha naught. And it is easily apprehendable that since there is no acceleration along the horizontal direction, that is along the x-axis, we must have this velocity, initial velocity u naught cos alpha naught, fixed throughout the motion. So x dot is given by this. So this is the first integral of the acceleration, these two equations, and from them we can easily get the displacement, isn't it so? If we integrate this further, y becomes minus half gt square plus u naught sine alpha naught into t plus again a integration constant which is k. Okay, and if I think it is visible, this k is visible, I think. Okay, and what about x? X is nothing but u naught cos alpha naught t plus k prime. These are the two values. By integrating dx dt equal to u naught cos alpha naught, we get x equal to u naught cos alpha naught into t plus k prime. Now x and y are 0 at t equal to 0. So whenever we put t equal to 0, we get y equal to 0, that is k equal to 0. And here also, whenever we get t equal to 0, x is equal to k prime, which is 0. So we have from this relation x equal to u naught cos alpha naught into t. This is the relation of x and t, and we can easily eliminate t from these two equations. Let me write it clearly. Let me wipe it out and write this clearly, these two relations. Okay, one is x equal to u naught cos alpha naught into t, and another is minus half gt square plus u naught sine alpha naught into t. So if we eliminate t between these two, it is very easy to find what is t. T is x by u naught cos alpha naught. So we can easily put the value of t here, and it becomes x square by u naught square cos square alpha naught, isn't it so? Plus it becomes u naught sine alpha naught into t is x by u naught cos alpha naught. Okay, u naught cos alpha naught. So y becomes this, and we can easily rearrange it this way. And let us take this minus common, as well as let us take this g by 2 common from these two terms. Now we are left with x square by u naught square cos square alpha naught. Okay, now just see that the second term we have 2 into x by u naught cos alpha naught into we have the term u naught sine alpha naught, isn't it so? This term we have taken minus g by 2 common, so there will be t, there will be a 2 to adjust it with it, and there will be a g here, and this term we have left intact. Why? Because this is the a square term, so a square plus 2 into a into b. So to make it a whole square, we should add u0 square sine square alpha 0 square by g square and subtract it. So we write it like this. minus u0 square sine square alpha 0 by g square. Reasonable, isn't it so? This is the first term, this is the 2ab term, and we have added the square of this term and subtracted it. So what we have is nothing but y equal to, I am writing this expression here boldly. I need some space, so I am writing it here only. Okay, so y is minus g by 2. Let me write it like this. Y is equal to minus of g by 2, and we are left with these first. Oh, okay, I have done another mistake, which is that I have taken this minus g, so this will be minus, isn't it so? This will be minus, and then we have added these two terms. So these first three terms gives us x by u naught cos alpha naught minus u naught sin alpha naught by g whole square, and this minus u naught square sin square alpha naught by g square is left aside, and when we multiply this with this g by 2, then the whole of this expression becomes y is equal to minus g by 2 x by u naught cos alpha naught minus u naught sin alpha naught by g whole square. And what is this term? This term is u naught, minus minus makes it plus. So this becomes this term becomes minus minus plus, and we have this one g cancels out, and it becomes u naught square sin square alpha naught by 2g. Okay, now let us rearrange it. How? We transpose this to LHS, and we have y minus u naught square sin square alpha naught by 2g is equal to minus of g by 2 x by u naught cos alpha naught minus u naught sin alpha naught by g whole square. Okay, if we write capital Y in place of y minus u naught square sin square alpha naught by 2g, and from here we prefer to take this u naught by cos alpha naught, extract it, then it becomes x minus, what it becomes, u naught sin 2 alpha naught by g whole square. Isn't it so? Because if we take 1 by u naught cos alpha naught common, then you have to multiply with u naught square sin alpha naught cos alpha naught, and we multiply with 2. Then in the numerator we have 2 sin alpha naught cos alpha naught, which makes it sin 2 alpha naught, and here 2g, and we write capital Y equal to, this is capital Y and this is capital X. So capital Y equal to minus G by 2 U naught cos alpha naught x square. And this can be written as x square equal to minus 2 U naught cos alpha naught by G into Y. So this can be compared, this equation can be compared with this form, because we know that x square equal to minus 4ay. What is the pictorial representation of this? We know that if x is this and y is this, x square minus 4ay is like this. So what we have done here is that we have shifted the origin to this highest point. And what is the highest point? The highest point is u naught square sine square alpha naught by 2g. And here it is u naught square sine 2 alpha naught by 2g. And then we have this type of equation. Okay. So this is as far as the projectile motion of a particle moving in 2 dimensions under gravity is all about. Now let us extend this idea to a particle which is moving in a medium under gravity the initial velocity is same, but in this medium we have a extra resisting force, motion in a resisting media. We all know that in resisting media we mean that the medium offers a resistance. There may be wind, there may be rain or whatever. We assume the resistance of the media as proportional with velocity or proportional with square of the velocity, whatever. Then the equation of motion, which we have written earlier as, we know that we have earlier written the equation of motion like this, motion under gravity. But if there is a resistance which is proportional to the velocity of the particle x dot and y dot, what is the velocity? U. And u is nothing but, you should remember, u is nothing but x dot square plus y dot square at the point P, which it reaches at a particular time. This is the initial time at t equal to 0, and the particle is projected with initial velocity u naught cos alpha along x-axis and u naught sine alpha along y-axis. Okay. So what is the equation of motion if there is a resistance which is proportional with the velocity? Then we should write the equation of motion like this, because the resistance is always acting in the opposite sense of the acceleration. So it will resist the acceleration, the resistance, and it is proportional with velocity. So we have written like this, and this can be easily integrated in this form. See, x double dot equal to minus kx dot gives this, and y double dot equal to minus g minus ky dot may be written as this. We can take this minus k common from both of these terms, so that it becomes g by k plus y dot, isn't it so? And this y double dot may easily be written as d of y dot plus g by k by y dot plus g by k, and we have here minus k dt. This can easily be understood because y double dot is ddt of y dot, and ddt of y dot may as well be written as ddt of y dot plus g by k. Since this y dot plus g by k is taken in the denominator, and this dt goes over there, and if we integrate this expression, obviously we have what we have. Integrating this equation, we got log of y dot plus g by k, isn't it so? In the denominator there is the y dot plus g by k, and in the numerator it is d of that. So niche function opore derivative holo amra jani log of y dot plus g by k hoy, and it becomes minus kt, plus there is a integration constant, and that can as well be adjusted, and here also we have log x dot equal to minus kt. It is also quite clear. We can write it here. What is x double dot by x dot? Obviously it is d of x dot by x dot, and here it is minus k dt, and whenever you integrate them it becomes log of x dot is equal to minus kt plus c, and this can be arranged. We can put it as log of k naught, so that it becomes log of x dot minus k naught, or x dot by k naught equal to e to the power minus kt, that is x dot equal to e to the power minus kt. And similarly from here also, if we replace the c by log of k prime, then from this equation we can write that y dot plus g by k gives us k naught prime e to the power minus kt, isn't it so? Because whenever we put in place of c log k prime and log k naught prime, then log of y dot plus g by k minus log k naught prime becomes minus kt. So log of y dot plus g by k naught prime becomes e to the power minus kt, and y dot plus g by k is equal to k naught prime e to the power minus k. And then we put this initial condition to these two equations, so that we get from these two equations, we easily get from these two equations, using this initial condition that at t equal to 0 we have x dot equal to this and y dot equal to this. Just put t equal to 0 here. So x dot is u naught cos alpha naught. So x dot will become u naught cos alpha naught e to the power minus kt, because whenever we put t equal to 0, it becomes 1, and k naught becomes u naught cos alpha naught. And here also, whenever we put t equal to 0, this becomes k0 prime, and this becomes u naught sin alpha naught plus g by k. So y dot plus g by k is nothing but, what is k naught? K naught is u naught sin alpha naught plus g by k e to the power minus k, and we have y dot equal to this minus g by k, isn't it so? So this is the change when we have resisting media, but the resistance varies as the velocity.